What's up out there in the www dot what all that other stuff is? Okay, this is the last one that you have to endure this semester anyway. Okay, this one is what is it? Factor and solve. Okay, remember the first thing you do when you want a factor of binomial or trinomial is you set this equal to 0. We're going to add 60 side, and we end up with b squared plus 16 equals 0. Now this is the sum of two perfect squares. And this is not a conjugate. Remember, a conjugate would be the difference of two squares. So this you cannot factor. So the answer here is prime. Cannot be factored. Number 22. Solve the systems of equations. By any method you want. Okay, so if we have 2x plus 5y equals 21, and you have 3x equals 6y minus 12. System of equations. So what we want to do is, first of all, let us, remember you want to put these in standard form. And standard form is ax plus by equals c. The c is the constant, the numbers. So the only one we have to really change here is this one. Subtract 6y from each side, and you end up with 3x minus 6y equals negative 12. Okay, so now remember this equation and this are the same, we just rearranged them. Okay, I'm going to go ahead and bring this one down here so we can see it a little better. 2x plus 5y equals what in the world have I done? I don't know. Equals 21. Now, I'll tell you what we can do here is let's take this equation and divide it by 3. That way we'll get x equals something. Okay, so we'll have 3x minus 6y equals negative 12. Divide by 3, we get x minus 2y equals negative 12. Now we want to know what x is so we can put it back into the other equation. Hope this makes sense. Okay, so we want to get x over here by itself. So we add 2y to each side, and we get x equals 2y minus 12. Now we plug, remember, this equation and this equation, those are the same. Now what we want to do is put x into the other equation, and that is 2 times x, but we know that x now is 2y minus 12. And then we just bring the rest of this down. Plus 5y equals 21. Now we do distributive property here. We get 4y minus 24 plus 5y equals 21. Right? Right. So 4y and 5y is 9y minus 24 equals 21. We add 24 to each side. 9y equals 45. That's a y there. Divide by 9. Y is 5. Now we plug this. Why don't we plug it back into this one? Remember, this equation and this are the same. They just look different. So we get, let's bring this down here. X equals 2 times y. Y we know is 5 minus 12. So x equals 10 minus 12. So x is negative 2. And that is our answer here. It's where the two lines cross. It's the intersection of negative 2, it's the intersection of the two lines. And now we really need to plug these back into the original equations. Negative 2 for x and 5 for y. That's negative 4. So we get negative 4 on one side. Plus 25. Does that equal 21? Yes, it does. 25 minus 4 is 21, so it works. Now the other one is, remember, it has to work for both of them. Negative 2 for x and 5 for y. So we have here 3 times negative 2. Does that equal 6 times 5 minus 12? This is negative 6. And does that equal 30 minus 12? 30 minus 12. Is that right? 30 minus 12 is 18. So this is not a good solution. This would be undefined. I think the one on the test, it is correct. Whatever bonehead did this, did it wrong, apparently. Now, what if we have this? 23, 3x plus 6y equals 24, and x equals 11 minus 2y. Again, what system of equations? Again, what we want to do is put this in standard form, so we want to get the negative 2y over to the other side. So we add 2y to each side. And we get x plus 2y equals 11. And I'm going to, this equation is the same as that one. I'm going to bring this one down over here so we can see them more easily. 3x plus 6y equals 24. You know what we should have done here? What a bonehead I am. Look, this is already solved for x, right? So we're going to take the x and plug it into there. 3 times x, x is 11 minus 2y plus 6y equals 24. Distributive property here, we get 33 minus 6y plus 6y equals 24. Now look, 6y minus 6y is 0. Well, let's go ahead and do this. Subtract 33 from each side. 6y minus 6y is 0. Does not equal, what is it, 19 or something? Come on, stupid, think. -9. So the solution set here is the null set. We could have just left this over here, because when that's eliminated, 33 does not equal 24, so that holds true. 24. I'm gonna need more paper. Evaluate by rationalizing the denominators. I still think that sounds like a disease. R-A-T, rational, C-I. Rationalizing the denominators. Remember, the denominators are the ones on the numbers on the bottom. Now on the test, it shows 18 divided by square root of 6. Now, that's the same thing as 18 divided by square root of 6. There's the denominator. We cannot have any irrational number in our denominator. Boy, does that not sound nasty. Okay, so what do? We're going to multiply by square root of 6 over square root of 6. Square root of 6 divided by square root of 6 is 1. Any number divided by itself is 1. So we're not changing the look of this any. We're just changing its value. I'm not changing the value. We're just changing the look of it. Okay, so this is, now when we multiply fractions, we do it straight across. Simplest thing you can do with a fraction. So we have 18 times the square root of 6 divided by, remember when you multiply the square root of anything by itself times itself, the radical just goes away. Now, we can reduce this. 18 divided by 6 is 3, square root of 6. Okay, 25. Same thing. 5 divided by 2 minus square root of 7. Okay, the only way you can get rid of the square root of 7 is to multiply by its conjugate. First, take a drink of your Diet Coke. I just spilled my Diet Coke all over me. Okay, so we want to multiply this times, its conjugate. And the conjugate of this is 2 plus the square root of 7. 2 plus square root of 7. Okay? Now, remember, the fraction bar makes this like it's in parentheses. So we have 5 times 2 is 10 plus 5 times the square root of 7 divided by. Now remember, when we multiply two conjugates, all you really have to do is multiply the first numbers and the second numbers 2 times 2 is 22. Oh yeah, 4. And remember, when you multiply the square root of any two numbers that are identical, the radical just goes away. Now, I'm sorry, a negative times a positive is a negative 7, right? Right. Mm-hmm. So this is 10 plus 5 times the square root of 7 over 3. I'm sorry, negative 3. Stupid boy. Okay, now remember, if you're going to reduce this fraction, it has to, when you have a plus or a minus here, you have two terms. And you have to be able to divide both of them, not just one. And thankfully, none of this is reducible. No, that's excuse me, that's our answer. 26. Okay, combine radical expressions, RADICASS. Combine radical, what the hell does that mean? Yeah, radical is the square root. Okay, that's the radical, right? The square root symbol. So 26 is 7 times the square root of 17 minus 5 times the square root of 13 plus 6 times the square root of 17. Now remember, for these things to be like terms, the index, remember there's a 2 in here, we just don't write it. The indices have to be the same, and the radicand has to be the same. Radicands are the numbers under the radical. Okay, so these two are like terms. This one is not. So 7 square root 17 plus 6 square root 17 is 13 square root 17. Don't forget this. Minus 5 square root 13. Okay, and that's our answer. 27. Well, I tell you what, I don't know what my problem is with wasting paper. Must have burned down a forest when I was in a previous life. 27. 3 times the square root of 8 plus 10 times the square root of 18. Oh, that's all. Okay, so what do we do here? We need to factor this number, the radicands, into something that has a perfect square. So this equals 3 times the square root of 4 times 2, right? 4 is a perfect square. 2 is not, plus 10 times the square root of 9 times 2. So this equals, now the square root of 4 is 2, so it comes out of the radical. So it's 2 times 3 times the square root of 2 plus 3 times 10 square root 2. So this gives us, what is it, 6? 6 square root 2. Come on, stupid. Plus 30 square root 2. Are these like terms? Yes. So we have 6 times 30 is 36 square root 2. What could be more fun? Okay, same stupid problem. Why didn't I give you something else? Like the cubes and stuff like that. Factor a cube. Why didn't I do that? Stupid boy. 28 is 5 times the square root of 54 plus 10 times the square root of 24 minus 11 times the square root of 96. Okay, now what can we factor out of all three of these? 3. 5 times 3 times 18. What? Plus 10 times the square root of 8 times 3. Minus 11 times the square root of 32. Okay, now we have to equals this. Equals 5 square root 3 times 2 times 9 plus 10 times the square root of 4 times 2 times 3. Okay, 8 is 4 times 2. Minus 11 square root of 16. This would be times 3. I'm sorry. I'll do better. 16 times 2 times 3. Okay. Okay, the square root of 3 times 2 is 6. Square root of 9 is 3. So this is 3 times 5 plus 10. Okay, square root of 4 is 2. So it's plus 2 times 10 times the square root of 6. And the square root of 16 is 4. I'm going to put the 11 first here. Times 4 times the square root of 6. Square root 6, square root 6, square root 6. Right. So we have 15 square root 6 plus 20 square root of 6 minus 44 square root of 6. Okay, 15 and 20 is 35. 35 minus 44 is a negative 9 square root 6. Right? 29. Yeah, we're almost there. Okay. Evaluating the lowest terms. Square root of negative 81. Now remember, when we have a negative under the radical, it just comes out as I. Square root of 81. So this is plus or minus. Square root of 81 is 9. I. You can put I9 on there if you want, but we typically, you can think about the I as a variable, and we usually put the variables at the end. Now, number 30, last one. Square root of negative 300 is, okay, the negative comes out of the radical as an I. Square root of 300. We know that that's I times the square root of 3 times 100. So this equals square root of 3. We don't know and we don't care. The square root of 100 is 10. I square root 3. Actually, it's plus or minus. Right. That's it. That's the last one of these you have to endure. I hope y'all have a Merry Christmas. Take care. Please be safe out there on the road. It's very dangerous out there. Okay, bye-bye. Hope to see you again sometime. Bye, Bonds.